Welcome to qnawire.
Okay, question 5 is saying that the nation of Ectenia has 20 competitive apple orchards. So there are 20 firms in total, and each apple sells at $2. All right, and we have the following production function, which is Q equals to 100 times L minus L squared. So the marginal product of labor is 100 minus 2L. So Q is the number of apples they produce in a day when they use this L number of labors. Okay, so A, what is each orchard labor demand as a function of the daily wage W? And what is the market's labor demand? So we know that if we have this MPL, this marginal product of labor times 2, which is the price of the product, which is the price of the apple in this example, is the value of marginal product of labor, which is 2 times this number. So it becomes 200 minus 4L. So in equilibrium, this value is equal to wage. Okay, so the answer for question A is just this. So wage equals to 200 minus 4L. And what is the market's labor demand? So if we rearrange this equation, we get that L equals to 200 minus wage divided by 4. So this is the labor demand for one firm. But now we know that there are 20 firms. So the total labor demand will be 20 times L. So total labor demand is big L equals to 20 times this number. So it is going to be 1,000 minus 5 times wage. So if we look at the graph, so if we try to draw this equation here, so it's a function of wage and labor. So when the wage is 200, this firm is willing to hire 0 labor, right? And when the wage is 0, this firm is willing to hire 50 laborers. Okay, so this is the labor demand curve for one firm. But now we have 20 firms, right? So to draw this big L here, we just have to sum up all this small labor. So we see that, okay, if there are 2 firms, this x-axis becomes 100, right? Because we sum the demand up like horizontally. So 3 firms goes to 150. So if we sum like 20 firms, this demand curve is going to be something like this, which is like super far away. And this point is 1,000. Why is it 1,000? Because each firm is willing to hire 50 laborers when the wage is 0, right? So if all 20 firms do the same thing, they're all in total, they will hire 1,000 laborers. So this blue line here is the demand curve for the total market, which is also what we have here, this equation. Okay, so question B is saying that if this country has 200 workers who supply their labor inelastically. So the blue line here is the labor demand curve. So now the question told us that, okay, now the labor supply curve is, I think I should redraw a graph. Okay. So now we know that we have this old labor demand curve, which looks something like this is W, this is L, and we just say that this is 200. When the wage is 200, people will we demand zero labor, and when the wage is 0, we demand 1,000. So I'm drawing the blue line right here, but in a different scale. Okay, so this is the labor demand right here. And now question B tells us that we have an inelastic supply of 200 laborers. So it means that the supply curve is vertical, so S. So given this information, we can solve the equilibrium wage, which is the point right here. So we just have that this demand curve looks something like this. L equals to, so L demand equals to 1,000 minus 5 times wage. It has to equal to labor supply, which is 200 in this case. So with this equation, we can solve for the equilibrium wage, which is, so here. So this term is 800. So W is 160. Okay, so this is the equilibrium wage, and this is the equilibrium labor supply and demand. So how many workers each orchid hire? So this is the total, in total, the equilibrium labor. So since there are like 20 firms, right? So each, small l, so each firm hires 10 labor. Because this number divided by 20 firms equals to the number that each firm hires. Okay, so how much profit does each orchid owner make? So to calculate the profit, we have to see how many apples they produce. So if we go back to the production function, which is right here, we plug in what we have, the small l equals to 10 here, to see that how many apples they produce. So Q equals to 100 times L, which is 10 here, and so it's going to be 1,000 minus L squared. So the square of 10 is 100. So we know that each firm produces 900 apples. Okay, so we go back here. So to calculate the profit is just the price of apple times how many they produce minus the cost. And the cost here is the wage of the worker times how many worker you hire. So it is equal to P, we know the price of apple is 2, times quantity of apple is 900, as we just calculated in the previous page. Okay, and what is the wage? The wage is 160 here. And how many labor do we hire? 10. So we can see that the profit is 1,800 minus 1,600. So the profit of the firm is $200. Okay, so question C Calculate what happens to the income of workers or orchid owners if the world price doubles to 4. So if the world price doubles to 4, what we have to change is, so I write everything different in green color. So this VMPL is going to be 4, because the price of apple doubles, 4 times MPL. So it is going to be 400 minus also 4 times 2, so 8L. So this new labor demand and wage relation is going to be, this is like 400 minus W. Oh, no, I was wrong. So we have this new small l equals to 400 minus W divided by 8. So as we can see, the big L here is going to be, so this thing times 20, which is, if I further, 50 minus W. So this thing times 20 is 1,000 minus 20, so 2.5 times wage. So if we want to solve for the equilibrium labor supply, we know that the labor supply is always 200 because it's fixed. So in this case, the new wage, say W prime, is going to be 800 divided by 2.5. Sorry, I need my calculator. Is 320. Oh, so we know that the new wage is double of the old wage. So it is easier if we just look at this equation, because we know that wage is always double of VMPO, right? So since now we know that the VMPO is double, wage is also double. So what about the profit? So the profit here, P turns to, so now P turns to 4, while the quantity, so the quantity now is, so each firm still hires 10 laborers. So the quantity does not change. So the quantity is still 10. So the quantity of labor they hire is still 10, and then plugging the production function, which is 900 as I remember. Okay. And minus this new wage is 320 times 10. So it is going to be 3,600 minus 3,200. So 400. So the profit will double. Okay, now D, suppose the price is back at 2, but a hurricane destroys half of the orchid. So Q becomes, so now we use this old price now, but Q becomes half because the hurricane destroys everything. And how does this affect the income of each worker and the remaining orchid owner? So what about the, so if we go back to this equation, we see that they still hire 10 laborers, I think. Yeah, so they still hire this number of labor and then produce this amount. But the apple they produced were destroyed. But they still have to pay the worker at this wage. So the final profit is 900 minus 1,600. So they generate this negative revenue of minus 700.